The next time you pour a bottle of expensive, full synthetic motor oil into your engine, pause for a second and imagine something. Picture a spotless laboratory. Engineers in white coats. High-tech machines carefully building perfect lubricant molecules from scratch. Designed specifically to protect your engine from brutal heat and metal-on-metal stress. That's the image most drivers have in their minds when they see the words full synthetic printed across the bottle. But here's the twist most people never hear. That oil inside the bottle, the one that just cost you $40 or $50, may have started its life exactly the same way as ordinary oil. Pulled from the ground, refined, filtered, and then marketed with a word that completely changed the entire motor oil industry. Synthetic. And the reason that word appears on so many bottles today traces back to a single decision made almost 3 decades ago. A decision that quietly reshaped the engine oil market forever. Today we're taking a closer look behind the label. We're going to explore the chemistry, the marketing, and the real differences between the oils sitting on store shelves right now. Because here's something most mechanics already know. Not every full synthetic oil is built the same way. Motor oil isn't just one thing. Every bottle is built from 2 main ingredients. The first is the base oil, the actual lubricant that coats and protects the moving parts of your engine. The second is the additive package. Detergents, anti-wear compounds, corrosion inhibitors, friction modifiers, small chemical helpers designed to keep engines clean and protected over thousands of miles. But the biggest difference between oils usually comes from the base oil. The American Petroleum Institute divides base oils into 5 major groups. Group 1 and Group 2 are traditional mineral oils refined directly from crude petroleum. They work, but carry more impurities and behave less consistently under extreme temperatures. Group 3 is still petroleum-based, but goes through intense processing using heat, pressure, and hydrogen to remove impurities and reshape the molecules. Then we reach Group 4. This is where true synthetic oil begins. Group 4 oils are called PAO, polyalphaolefin. Instead of starting as crude oil, they're chemically engineered from smaller molecules through a controlled synthesis process. Every molecule is intentionally built. The result is extremely consistent molecular structures, like identical building blocks all the same size and shape. When every molecule is nearly identical, the oil flows well in extreme cold, resists breakdown under heat, and maintains its viscosity even after months inside a hard-working engine. For decades, this was exactly what the word synthetic meant. But something happened in the late 1990s that quietly changed everything. One oil company had built its reputation on true synthetic chemistry. Another released a new oil, also labeled synthetic, but made primarily from heavily refined Group 3 petroleum. The first company challenged the claim. Their argument was simple. If the oil begins as crude petroleum, how can it be called synthetic? The dispute went to an industry advertising review board, and the decision surprised many engineers. The ruling concluded that because the intense refining process significantly changed the oil's chemical properties, it could legally be marketed as synthetic. That single decision changed the motor oil industry forever. Suddenly companies could use less expensive Group 3 base oils, refine them heavily, and still print full synthetic on the bottle in bold letters. Over time, many brands quietly adopted this model. The oil still passed certification tests. It still protected engines. But the chemistry wasn't always what drivers imagined when they handed over $50 at the register. Walk into almost any auto parts store and you'll see familiar names. Castrol, with products like Castrol Edge, emphasizes high-performance engineering and advanced additive technology. Their additives are genuinely sophisticated. But in many formulations, the base oil is primarily Group 3, highly refined petroleum rather than laboratory-built PAO molecules. For normal driving and regular oil change intervals, it performs very well. But the chemistry is different from original PAO-based synthetics. Another historic name is Valvoline, around since the 1800s and trusted by drivers and mechanics for generations. Earlier synthetic formulas relied more heavily on PAO chemistry. But many mainstream synthetic products today use hydroprocessed Group 3 base oils instead. For everyday vehicles under normal conditions, it still works perfectly well. Then there's Quaker State, now owned by Shell plc. Inside large companies like this, different product lines can use entirely different base oil technologies. Some formulas rely on advanced base stocks, while others use conventional Group 3 oils. From the outside, the brand looks the same, but the chemistry inside can vary depending on the product tier. There's also a fascinating technology that begins somewhere completely different: natural gas. Instead of refining crude oil, natural gas can be converted into liquid hydrocarbons through a process known as Fischer-Tropsch synthesis. This produces extremely pure base oil with very consistent molecular structures. That technology is used by Shell in oils like Shell Helix. These are often classified as Group 3+, performing exceptionally well and behaving similarly to PAO synthetic in many tests, though technically classified differently from true Group 4 synthetics. Then there are the oils many drivers buy simply because they're affordable: store brands and retailer labels. These products are usually manufactured by large lubricant companies and packaged under retail names. They almost always rely on Group 3 base oils to keep costs manageable. For drivers who change oil regularly under normal conditions, these oils perform perfectly well. The lower price simply reflects the base oil chemistry used. Now here's the most important question: does any of this actually matter for your engine? The honest answer is, it depends on how the vehicle is used. For most daily drivers, commuting, errands, highway travel, a high-quality certified synthetic based on Group 3 oil works extremely well. Modern engines are designed with tight tolerances and advanced lubrication systems. As long as the oil meets certification standards and is changed on schedule, engines can easily reach very high mileage. Where the differences begin to appear is under extreme conditions. Turbocharged engines create enormous heat. Heavy towing places continuous load on the engine. Very long oil change intervals push oil far beyond typical limits. In those situations, PAO-based Group 4 oils offer better resistance to thermal breakdown and improved stability. The molecules simply hold together better under prolonged stress, because they were engineered to, not just refined into shape. That's why many high-performance oil manufacturers openly advertise their base oil technology. When a company uses expensive PAO chemistry, they want drivers to know about it. Once you understand all of this, walking down the oil aisle becomes a completely different experience. You start noticing the certifications, the viscosity numbers, the technical language on the bottle. Suddenly, those containers aren't just colorful packaging anymore. They're chemical tools designed to protect one of the most complex machines most people own: your engine. And when that engine is spinning thousands of times per minute, with metal parts moving within fractions of a millimeter of each other, the thin film of oil between them becomes one of the most important protective layers in the entire vehicle. Understanding how it works helps you make smarter choices instead of relying only on marketing. Now I'm curious about something. What motor oil are you running in your car right now? Drop a comment below and tell me the brand, and also tell me which country you're watching from. And if you enjoyed uncovering the hidden science behind engine oil, make sure you like the video and subscribe for more deep dives into the secrets of car maintenance and automotive engineering. Because the more you understand how your car works, the longer it will take care of you on the road.